1. All right, so 5.7, distance on a coordinate plane. Remember, a coordinate plane has our 4 quadrants. If we, when we're plotting on the coordinate plane, we're going to the right or to the left, right, and then up or down. We have x, y coordinates. If our x, remember x is to the right or to the left. If it's positive, you go to the right, negative, you go to the left. And then our y is up and down. Positive, you go up. Negative, you go down. So those are prerequisites. Today, we're going to do this in 2 different days. So 5.7 is day 1 is going to be just calculating the distance on a coordinate plane using the Pythagorean theorem. So it's going to be pretty short. We have 3 examples that we're going to do. Okay, and then tomorrow we will actually use what we call the distance formula. Okay, so first, calculating on the distance on a coordinate plane, the first thing you have to do is you have to plot the given points. So that they're going to give you 2 points and you want to plot them. So after you plot your 2 points, you're going to draw a right triangle using the line between the given pairs as the hypotenuse. So what you're going to do is you're first going to connect the 2, and then from one point to the next, you need to go to only using horizontal and vertical lines. And it'll make more sense when we do an example. After that, you need to find the lengths of the legs and then plug them into the Pythagorean theorem and solve. And remember that our Pythagorean theorem is a squared plus b squared equals c squared. Okay. So we have our first example. Graph the ordered pairs 3, 1, and 7, negative 5. Then find the distance c between the 2 points. So on a coordinate plane, we need to find the distance between 2 points. Now, if you, I'm going to use this example first. If I have 2 points, say here to here, you can't just guesstimate and say, well, this is 1-ish, 2, 3, 4, right? It's not going to be 4 exactly. It's going to be partial, right? Unless you go through, say, like from here to here, that would be 2 exactly, because you're going straight through the middle. Okay? So what I mean by that is you can't just count the distance between them unless it's a horizontal vertical line, right? So what I need to do is plot the points first. So again, I want to go 1, 2, 3 over because my first number is positive. And my second number is 0, so I want to stay there. So 3, 0. Good on that one? Okay, then 7, negative 5. My first number is 7, so I go over to 7 and down negative 5. Okay, so now I want to connect these 2 with a straight line. This straight line is actually my hypotenuse, or my C. Now, I want to go from this point to this point only using horizontal and vertical lines. So I'm going to go straight down and then straight to the right. Do you see how I only used horizontal and vertical lines? Okay, if I really wanted to, I could have went this way. I could have went to the right first and then down. Okay, do you see what I'm saying? The next thing we need to do step is then counting how long the legs are. So 1, 2, 3, 4, 5. So this would be 5. This would be 1, 2, 3, 4. Do you see how I counted the length of the legs? All right, so then I'm going to plug them into the Pythagorean theorem. The legs being A and B. So a squared plus b squared equals c squared. A can be 5. B can be 4. We have to remember order of operations. We want to square our numbers first. So 5 squared is actually 5 times 5, which is 25. 4 times 4 is 16. Someone be my calculator? Anthony?
What?
25 plus 16 is 41. Oh, I can't forget my squared. Okay, I need to find the square root of both sides. So C is actually 6.4. So the length of this here, this side, is actually 6.4 units. Okay? Any questions so far? Let's do the second one. 1, 3. Go over to 1 and up to 3. Plot the point. Negative 2 up to 4. Negative 2 up to 4. Plot the point. Connect the 2 points with my hypotenuse. So this is my C. I need to go from this point to this point using only vertical and horizontal lines. So go straight down, straight to the right. I need to count my number, or how long my segments are. So this would be 1. This would be 1, 2, and 3. I'm going to put that into a squared plus b squared equals c squared. So 1 squared plus 3 squared equals c squared. 1 times 1 is 1. 3 times 3 is 9. So again, the order I do this, I have to square the numbers first and then add them. 1 plus 9 is 10. Calculator man? Square root both sides. 3.16. We want to round it to 3.2. Okay? There you go, Anthony. And my last problem, 1, 5, over to 1 and up to 5. So 1, 2, 3, 4, 5. Over to 3, 1, 2, 3, and up to 1. So connect these two. And then I want to connect it with my horizontal and vertical lines. And do you see how this right here, these two create my right angle? So these two are my legs. This side is 2, this side is 1, 2, 3, 4. So I'm going to put 2 squared plus 4 squared equals c squared. 2 times 2 is 4. 4 times 4 is 16. Add the two numbers together, you get 20. C squared, 4.47. So 4.47 rounds to 4.5. And we could actually label it units. Okay. Your assignment.
That was fast.
That was very fast. Your assignment is page 435, numbers 1, 2, 3, number 8, 14, 15, and 21. You can also rip out your page in your note or in your book if you want to take the the coordinate plane from the book and use it for your homework.